Hello students. So in this video we'll start the new chapter which is classification of elements. Students, to discuss about like why do we need to classify the elements, first of all, what is an element? Just answer what is an element. Define an element. Element means atoms of same type is called as an element. Yes or no? Everything, the whole matter is made up of atoms. Yes or no? All these atoms are the same? No, they are different. What do they differ by? Number of protons. That each different atom is called as an element. Yes or no? Atoms of same type is called as an element. An atom with one proton, a particular element, one element, first element. An atom with two protons, second element. An atom with three protons, third element. An atom with four protons. An atom means only one atom. Millions of atoms contains three protons. Yes or no? All these atoms comes under the third element. Millions of all the atoms which contains four protons comes under fourth element. Like that, how many elements do we have? Including naturally found and artificially synthesized, we have almost like 118 elements are there. Okay, all the atoms are classified into elements. But again, why do we need to classify the elements also? Right, the reason is, students, these elements, in these elements, some elements they show similarities. Some elements they show similarities. Sir, what type of similarity? Similarities in terms of physical nature, similarities in terms of chemical nature also. What is physical and what is chemical nature? Physical nature means its physical state, solid, liquid, gas, melting points, boiling points, yes or no, shape, color, taste, order, appearance, all comes under physical properties. And what are chemical properties? How it is reacting with oxygen, how it is reacting with chlorine, how it is reacting with acids, how it reacts with bases, how it reacts with water. These are chemical reactivities. So how can we understand all this? Do we need to study all 118 elements separately? No, it's a very hard process. Yes or no? Definitely we need to simplify the concept. When the concept can be simplified? When we classify the concept. Anywhere, classification helps us to study in a simpler format, in an easy format. That is the use of classification. So here also we have the classification. So what is the main use means? To study the elements in a systematic manner, in a particular way. So this element, next this element reactivity, both have same reactivity, next, like that. A systematic way of understanding the chemical reactivities of all these elements. Next, to correlate the properties of the elements, the same, to relate all the properties of certain different elements. In all these different elements, I already have said, some elements have same chemical reactivities, yes or no? So to understand that relation between their chemical reactivity, we need to classify the elements. To know the type of different compounds that different elements can form, right? The same, ultimately chemical reactivity, how these elements can combine, how hydrogen combines with oxygen. What is the formula? H2O. If sodium combines with oxygen, Na2O. If potassium combines with oxygen, K2O. There is some relation, right? 2:1, 2:1, 2:1 ratio. Why? To find that relation, to understand that relation, we need to classify these elements. So these classifications, like you already know, there is modern periodic table. So is that the only first classification? No. From the olden days, student, there are many classifications are being attempted by different scientists, and definitely there are some valid points and there are some invalid points also. We have to study all these early attempts of periodic classification of elements. The very first classification is given by the scientist Lavoisier. Lavoisier classified the elements into metals and non-metals, mainly two groups, students, metals and non-metals. So what are metals, students? At that time, in the year around 1860s, at that time only few elements were there. In these few elements only classified into metals and non-metals. And how can we define metals, students? Metals means elements which are lustrous in nature, malleable, ductile, sonorous. They are called as metals. Yes or no? How can we define metals in terms of chemical reactivity? Elements which show tendency to lose electrons are called as metals, right? Next, what are non-metals? Elements which are non-lustrous, that means they don't show any shiny nature. They are non-malleable, they do not show any malleability. That means making a metal into an element into a thin sheet, that is malleability. Non-ductile, non-sonorous, they are called as non-metals. How can we define in terms of chemical reactivity? Elements which can gain electrons are called as non-metals. So this is the classification which is done by the scientist Lavoisier. But what is the problem with this classification, students? This classification is okay, but in metals also, some metals are losing one electron, some metals are losing two electrons, some are losing 3 electrons. Yes sir, there is a difference in losing also. Similarly, there is a difference in gaining also. So this classification is a broad, like only 2 metals, non-metals. Still we need to classify them. So this is not the perfect classification to classify all the elements. So this is one of the early attempt. Okay, that's good classification only, but based on this we cannot classify all the elements, right? So next classification, and as well as students, there is one more set of elements are there called as metalloids. These are elements which have both metallic nature as well as non-metallic nature. They are called as metalloids. We will see these metalloids in the modern periodic table. So that's why not only metals and non-metals, metalloids, noble gases. So all these type of elements are there. So these elements cannot fit under metals and non-metals. Yes or no? So that's why this classification is not valid over the period of time. Next significant classification is given by the scientist Dauberinier, and his classification is called as law of triads. Simple. Triad means what? Tri means what? 3. He placed 3 elements in a group. He placed 3 elements in a group, and that group is called as triad. That's it. 3 elements in a group, and that group is called as triad. Okay, he placed 3 elements in a group. What is the relation he gave? The relation he gave is, students, first of all, I'll show you the elements. For example, lithium, sodium, potassium. He classified these 3 elements in a triad. Other triads are also there, mainly this triad. So in this triad, students, he said the atomic mass of the middle element in a triad. What is the middle element in this triad? Sodium. Yes or no? The atomic mass of this sodium is the average of atomic masses of first and third element. That is law of triad. That's it. What is law of triads? The atomic mass of the middle element in a triad is the average of masses of first and third element. What is the first element? Lithium. What is its mass, students? Lithium mass is 7 grams. Yes or no? What is potassium mass? Potassium mass is 39 grams. So what is the average of lithium and potassium? So 7 plus 39 by 2, which is 46 by 2, which is 23 grams, which is absolutely the mass of sodium. Understood? Like that he classified few other groups also. What is triad? A group of 3 elements. In these 3 elements, middle element mass is the average of first element's mass and the third element's mass. This is law of triads. Is this classification valid? No. Yes or no? This is a completely invalid classification. And he didn't classify all the elements also. Only few set of triads he gave. And in this set of triads also, if you can check, students, look at here, chlorine, bromine, iodine. This is one triad, like horizontal you can check. Calcium, strontium and barium, sulfur, selenium, tellurium. These are the triads given by Dauberinier. And in these triads also, if you can check, look at chlorine's mass, how much? 35.5. Look at iodine's mass, 127. So what is the average of these two masses? 35.5 plus 127, 30, 157, 162.5. Yes or no? By 2, which is how much? 81.25. But what is the mass of bromine? 80 only. Is the average of first and third element? No. And other masses also not completely related. Then why he classified? At that time we don't have that sophisticated techniques to find the mass so accurately. Yes or no? Now we know. Now we have mass spectroscopy, everything. Now we know the masses exactly. At that time we don't know the exact masses, so he classified. That means whatever the triads which are given by Dauberinier, later on they are also not accepting his law. But only one triad which is accepted, that is lithium, sodium, potassium. Sir, why it is 100%? It's a simply coincidence. That's it. It's a coincidence. There is no relation according to that. First and third average, no. So, and he didn't classify all the remaining elements also. He got this thought, he applied for few elements and he gave the periodic table with few elements only. His law is not applicable for very low atomic mass elements as well as for very high atomic mass elements also. So, this law is also not completely applicable, the law of triads. So, disadvantages. This main drawback of this classification was that the concept was not applicable to all the known elements, but only to a limited number of the same point we discussed, not applicable for all the elements. So, Lavoisier, Dauberinier, the next classification is given by the scientist Newland. His classification is called as Newland's law of octaves. What is the classification, students? Newland's law of octaves. So he classified, you can see the periodic table of Newland. This is the periodic table of Newland. He classified some set of elements in this classification, students. This is how it looks like this. So his periodic classification starts from lithium, ends with calcium. So how he classified the elements? This classification has some little significance. Why? Because he is the first one to classify the elements based on increasing order of atomic masses. So that means, sir, the first element should be hydrogen. He didn't classify. Next, helium. He didn't classify. He starts with lithium. Why he didn't classify also I'll explain. See. So lithium, what is the next element? Beryllium. Next mass, next element means what? On what basis? Increasing order of atomic masses. After beryllium, boron. Next carbon. Next nitrogen. Next oxygen. Next fluorine. After fluorine, next is neon. He didn't classify neon. After sodium, look at here, sodium he again placed under lithium. Yes or no? And he continued again his classification. Why? Lithium is sodium showing the same reactivity. So same chemical reactivity. Magnesium is placed under beryllium. Why? Same reactivity. Aluminium under boron, same reactivity. Silicon under carbon, same reactivity. Phosphorus, sulfur, chlorine, potassium, calcium. Yes, sir, these three elements in the same group have same reactivity. Beryllium, magnesium, calcium, boron, aluminium, carbon, silicon, nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine. Like that he classified. Only till calcium only. Don't think, sir, at that time might be elements were not there. Gold is there from ancient times. Gold is an element. He classified? No. Silver is there. All these elements were not classified. Only few set of elements only classified. So for every classification, there should be some connecting idea. That idea is called as law. Yes or no? So let's see what is the law for Newlands. That law is called as law of octaves. He is a musical lover. So his classification, his law is based on music only. Let's see what it is. So he said, students, all the elements in the periodic table are arranged in such a way that every eighth element resembles its properties with the first element like musical notes. What are musical notes, students? Musical notes are sa, re, ga, ma, pa, da, ni and sa. Let's count all these musical notes. 1, 2, 3, 4, 5, 6, 7, 8. Look at the first sound, sa. Eighth sound, sa. Same sounding or not, first and eighth. Look at the first element, lithium. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. So lithium and sodium have same chemical reactivity. Why? Was first sound and eighth sounds are similar. So first element and eighth element have same reactivity. That is the reason he gave. Is there any sense in comparing these elements classification with music? Absolutely no. Yes, sir, no, students. But why? He gave that is applicable for this set. That's it. Let's count from beryllium. 1, 2, 3, 4, 5, 6, 7, 8. Beryllium, magnesium. That's why they are placed in the same group. Let's count from magnesium. 1, 2, 3, 4, 5, 6. If you count from any element, the eighth element is placed under that. Okay. So then why not all the elements are classified? So simple reason. If noble gases were added, for example, if neon is added. Now once read the law, every eighth element should resemble the first element. Count 1, 2, 3, 4, 5, 6, 7, 8. Now eighth element becomes neon. Does it show the same properties like lithium? No. His law will be ruled out. Yes or no? Sir, why don't he change his law from every eighth element to every ninth element? Then his law will be gone, his musical notes will be gone, reference will be gone. Yes or no? So that's why he simply excluded noble gases, helium, neon, argon, even hydrogen also for the same reason. After calcium also he didn't classify. Why? Because after calcium D block elements will start. In these D block elements also, first and eighth element they do not show any kind of similarity. That's why he left the elements after, he excluded the elements after calcium before lithium, even in between noble gases also. This is Newland's law of octaves. So what is the significance? You can see the same block of elements, same block of classification even in the modern periodic table also, students. Lithium, sodium, potassium, beryllium, magnesium, calcium. Then what is incorrect is the law. The law is, if you classify the element, that should be applicable for all the elements. Yes or not a simple block, not for 3 elements, not for one group. No. Yes or no? It should be applicable, it should be universal. So this law is not applicable for all the elements. That's why this is a drawback. Then what are the achievements? The law of octaves was the first logical attempt to classify the elements on the basis of atomic weight. So he's the first one to get to have this idea of getting the idea of classifying them based on their masses. And periodicity of the elements recognized for the first time. Periodicity means the regular arrangement, the regular chemical, showing similarity in the chemical behavior, that is called as periodicity. For example, lithium, sodium, potassium, they are showing same properties or not? They have same property. Lithium chloride, I'll explain what is the same, why do they same in the modern periodic table, that this is periodicity. So arranging the elements in a regular intervals of space with similar chemical reactivity. Beryllium, magnesium, calcium, they same similar chemical reactivities or not? Boron, aluminum, similar chemical reactivity. Carbon, silicon, same reactivity. Nitrogen, phosphorus, same chemical reactivity. Oxygen, sulfur, this is periodicity. So the elements are showing set of similar reactivity. Sir, what is reactivity? They combine in the same ratio. Carbon with oxygen, what is the formula? CO2. Silicon with oxygen, SiO2. That is similar reactivity. Sodium with chlorine, what is the formula? NaCl. Potassium with chlorine, KCl. Hydrogen with chlorine, HCl. Lithium with chlorine, Li 1:1 ratio. Sir, that is similarity. We'll discuss in detail in the modern periodic table. So, right, these are the achievements, like the ideas, and what are the disadvantages? Like I said, not applicable for all the elements. So this law is not could be best applied only for the elements till calcium. Newly discovered elements, noble gases, if you add, the law will be ruled out. It failed to exhibit the feature with heavier elements, like after calcium, heavier elements also. This law is not completely applicable, not applicable. So after Newland's classification, the next significant classification is given by the scientist Mendeleev, Russian chemist Dmitry Mendeleev, students, and he also classified the elements based on increasing order of atomic masses. He also classified based on increasing order of atomic masses. So, and he gave a law, and the law states that the physical and chemical properties of the elements are the periodic functions of their atomic masses. This law is called as Mendeleev's law. Very, very important. What is the law states? The physical and chemical properties of the elements are the periodic functions of their atomic masses. So what is the meaning of that law? The meaning is, students, Mendeleev classified the elements in such a way, based on the increasing order of atomic masses only. But every time, students, Mendeleev arranged all the elements in group as well as in period way. The top to bottom are called as groups, vertical columns are called as groups, and horizontal rows are called as periods. And all these elements are arranged in such a way that the elements with similar physical and chemical properties are placed in the same group. Elements with similar chemical properties are placed in the same group, but every time they are placed in a different period or not. This is one group, but all the elements are placed in different periods or not. This is called as periodicity. This is called as periodic function. Elements, how the elements are arranged? Based on the increasing order of atomic masses, as well as they are placed in the same group. And which elements? Elements which show similarity. Elements which show similarity. In the same group, every time they are placed in this different period. That is called as periodic function. Ultimately, all these elements are classified based on increasing order of atomic masses. So answer the question, where the elements can show similar chemical reactivity, in the same group or in the same period? In the same group, in a different period every time. Lithium, sodium, potassium, rubidium, yes or no? Different groups, different periods, same group. Next. So what are the characteristics of Mendeleev's periodic table? Like I said, groups and periods. He classified the elements into certain groups and periods. Vertical columns in the periodic table are called as groups. Vertical column, top to, these are groups, top to bottom. These are periods. Horizontal rows, these are called as horizontal rows. So there are 8 groups. These groups are numbered as 1, 2, 3, 4, 5, 6, 7 and 8 groups are there, and each of the group from 1 and to 7, 1 and to 7 are divided into subgroups. That means every group is again subdivided into A and B. And total how many groups are there? From 1 to 7 subdivided into A and B. And 8th group is not subdivided. Total how many? 15 groups are there in the including subgroups in the Mendeleev's periodic table. And there are 7 horizontal rows, they are called as periods. Total how many groups? 8 groups, Each group is again subdivided into A and B. 8th group is not subdivided. Why? I will explain. 7 groups only. 14 plus 8th, 1. 17 vertical columns, groups, and 7 horizontal rows. This is how the periodic table looks like. The Mendeleev's periodic table. Are we following this Mendeleev's periodic table? No. Why? I will explain, students, in the modern periodic table. See. So, what is the significance of this Mendeleev's periodic table? The systematic study of elements. Mendeleev is the first scientist to classify all the elements. You already have seen the early attempts of classifications, yes sir, students, and in all these classifications all the elements were not classified, but in Mendeleev's classification, whatever the law he gave, that law is applicable for all the elements. The law is applicable for all the set of elements. So that's a systematic study of elements. That means very less errors are there in this classification. So, and predictions of new elements. Predictions of new elements means while classifying the elements based on the increasing order of atomic masses, Mendeleev got some doubts. Based on these doubts, he left few spaces in the periodic table. For example, students, and here these spaces are completely filled right now, but during the classification times, he left this space, and this space he called as Eka boron, and he left this space also. He called it as Eka aluminum, which is under aluminium, and he left this space also. He called it as Eka silicon. The space after silicon is called as, students, Eka silicon. This is Eka silicon. So, sir, why did he left these elements? After zinc, the next available element is arsenic at that time. So, if you want to classify in the increasing order, he should placed here, yes or no? Then why he got this doubt of maybe some other elements are there? Simple reason. The reason is arsenic is not showing the properties with the third group elements, either A or B. It is showing the properties with fourth group. Understood? Simple. Arsenic is not showing the properties with the third group. It is showing similarity with the fourth group. So, what he thought, what is the thought? Might be some other elements are there which are undiscovered. Got the clarity, students? So, later on, boron, Eka boron is discovered as scandium, and Eka aluminium as gallium, Eka silicon as germanium. Not only the names, he even gave the melting and boiling points also, chemical reactivities also, and all are absolutely same. Correct. Well, sir, how can he give chemical reactivity? Element is only not there. How can he give chemical reactivity? You already know. Elements in the same group have similar reactivity. Yes or no? So, definitely gallium should resemble aluminium reactivity or not? Al2O3, Ga2O3, AlCl3, GaCl3. That's how it is. That's how it works. So, this is one of the advantage of Mendeleev's classification, predicting some undiscovered elements. Correction of atomic masses also. Mainly he corrected the atomic masses of indium, beryllium, platinum, osmium, these elements. Mainly beryllium. Beryllium atomic mass is, scientists thought it is like 13.5 grams in the, why? Because like impurities, because of the chemical impurities, by exact determining of atomic masses was not there. So, scientists believe the mass is 13.5 grams. He corrected from that value to 9 grams. So, 9 grams is the mass of beryllium, and now it is placed in its exact positions. Why correcting the masses? This classification is done according to the increasing order of masses only. So, correcting the masses definitely gives that particular element its perfect position, yes or no? So, that is a third contribution by Mendeleev. These are the main points. Classified all the elements in a systematic way, predicting undiscovered elements, correcting the atomic masses also. Then if this periodic table has this many advantages, why we are not following it? Why? Because there are many drawbacks also, right? That's why. Position of hydrogen. Hydrogen is showing the chemical reactivity with the first group elements as well as the seventh group elements. You can see hydrogen is placed here and here also. How come one element can give different positions, yes or no? If it is placed only in the seventh group, why not in the, if it is placed only in the first group, why not in the seventh group? If it is placed in the seventh group, why not in the first group? If it is placed in both groups, for one element, why two groups? Understood? This confusion is there. So, that's why one of the drawback. Next, anomalous pair of elements. Anomalous pair of elements means mainly it is seen for few couple of elements, students, for tellurium and iodine. Tellurium mass is like around 128 grams, iodine's mass is 127 grams. Do you find any dissimilarity? The answer is yes. Why? Because Mendeleev's classification is based on increasing order of atomic masses. for these set of elements, it is in the decreasing order. Yes or no? Is this correct? Wrong. Right? According to the classification, this is wrong. Iodine should get tellurium position, tellurium should get iodine position. But look at how he classified. Why he classified? Think. Why? Because tellurium is showing the properties of 6th group, iodine is showing the properties of the 7th group. So he strictly followed chemical reactivities. He know this classification for these two elements, they completely became a drawback, but he strictly followed chemical reactivity only. That's why the need of classification. Yes or no? To understand it, the reactivity only, na students. So he strictly followed chemical reactivity. He didn't explain the reason why for these two elements it is in the decreasing order. These are completely later on explained in the modern periodic table. Position of isotopes also. Isotopes means we discussed in the structure of atom topic, atoms with same atomic number, different mass number, right? Different mass number means they have different masses. Protium, hydrogen have 3 isotopes. Protium, deuterium, tritium. Protium mass is 1 gram. Deuterium mass is 2 grams. Tritium mass is 3 grams. Yes or no? And how Mendeleev classified the elements? Based on the increasing order of atomic masses. First to hydrogen, next helium. Why helium? After hydrogen, next deuterium is there. Next tritium is there. Next helium. Helium isotopes. Next lithium. Lithium isotopes. Next beryllium. Beryllium isotopes. Next boron. This is how he had to classify. Sir, why means increasing order of masses? The law. All the isotopes have different masses. But did he classify it? No. Sir, why he didn't classify it? Why? Because isotopes have same properties, right? Sir, no. Hydrogen have 3 isotopes. 3 isotopes have same chemical reactivity like hydrogen only, na? For the same element, if we giving different position, that is also will become a drawback. Sir, no. Lithium isotopes all have same reactivity. Proton is not changing, right? Neutron doesn't affect the chemical reactivity. So, but according to the law, he should classify, but he didn't classify because they show same reactivity. There is no use of classifying it. But it's a drawback. Why? His law is following based on atomic masses. Isotopes in different masses. He should classify, but if he classified also, it will become a drawback. Why? They show same reactivity. For same reactivity, why giving different positions, different groups? Got the clarity? Ultimately, he didn't classify. So, position of isotopes also, he didn't classify. That is also drawback. Next, position of lanthanides and actinides. You already know, at that time there is no concept of this S subshell, P subshell, D subshell, F subshell, D block elements. So all the elements are completely, classified in these groups only. So lanthanides and actinides, they didn't give any different separate positions like how they gave in the modern periodic table. Why, sir? Why they need to give different position? Why? Because almost all of them are radioactive elements. But see, they're simply placed under boron aluminum group. Do they have same reactivity? Absolutely no. Next, grouping the elements. So in this classification, students, almost all are correct only, but some heavier elements are placed in the highly reactive elements. Look at here, copper, silver, gold, they are placed in the first group. Yes or no? These are highly reactive metals. These are very, very least reactive metals. How come they show same similarity? Yes or no? These type of some mistakes are there. Even you can see manganese is placed in the non-metallic groups. Manganese, tellurium, these are metals but are placed in the non-metallic groups. They should give a different position like D block elements, how they gave in the modern periodic table. At that time there is no concept. So he simply placed all these elements in this subgroup concept. So these are the drawbacks of Mendeleev's periodic table, students. But this periodic table has a lot of significance. In terms of exam point of view also, you have to concentrate. So these are all the early attempts of classification of elements, Lavoisier's and Daubigny's, Newland's and Mendeleev's. The next classification, which is the ultimate classification, modern periodic table, that we'll discuss in the next video. Thank you, students.